Yeah, we'll go over your homework. If there's any questions, it's been sitting on the board for a while. These are questions 1 through 4. Comments, questions, concerns on any of these? Anyone want to see how they're done? They're relatively simple, I thought. Just getting you thinking. I don't know when the last time you had math is, so for some of you it's been a while. We good? Can I flip the page? We still looking? Yes, I see that hand. B and C in number 2, okay. So we want to solve for E. E is right there, trapped in the numerator. So we want to leave it in the numerator, but we want to get it alone. So what you can do is you can treat the denominator as one object. That expression can move as one big chunk. So what I did was I multiplied both sides by nr plus big R. nr plus big R. On this side, they cancel, and then I get C times nr plus R. And then that leaves me with NE on the right-hand side, and I divided both sides by N. So I get C, and then in brackets, NR plus big R over N equals E. So that was B. And you wanted C as well?
The one before that.
Oh, you wanted B and B.
Yeah.
Okay. So then this B, the typo, I got to fix that. Similar set of procedures, except instead of having something trapped in the numerator, I got a whole other. I got multiple terms, is what I'm trying to say, I guess. I need to get the terms that are furthest away from the variable I'm trying to isolate have to move first. So I want to solve for that A, so I'm going to subtract this VT over. It's going to give me D minus VT on this side, and it's going to leave me with half AT squared on this side. You good so far, Jasmine?
Yeah.
Okay. So that's. To get rid of the half, then I'm going to multiply by 2, and I'm going to multiply it on both sides. And so I've got my D minus VT, and to multiply that thing by 2, I just put that in brackets, and I multiplied the 2 over there. And that leaves me with AT squared here, so I just divided T squared on both sides. How do you feel about that? Feel good about that? Okay. Both of them? Both of the B's? Any other questions about any of these first 4? By first 4, I mean there's a whole lot more than 4 there, but. Okay. So then question 5 looks like that. I didn't give you units for depths, so I've got D equals 15 and D equals 40. Okay. Yeah, James? Oh, I did read that. I definitely missed that earlier when I was doing these things. Depths are in kilometers. Thanks, James, for reading the question more closely than I did. So then we've got to include our units. Comments, questions, concerns, either of those? Hearing nothing. Okay, let's go review some trig. Flip the page. Okay, so the vast majority of what we're going to be doing is going to be involving right angle triangles. So we're not going to need sine law. We're not going to need cosine law. You'll likely need those for physics in grade 12. We keep it a little bit simpler here in physics 11. If you know hands up, do we know sine law and cosine law? Hands up if you know sine law and cosine law. Hands up high. So I can. You did, but you forgot it. Okay, well, if we need it, we'll review it. The vast majority of what we do is going to be just the simple trig relationships and or the Pythagorean theorem. So, Pythagorean theorem is what? Manuel, I saw that hand first. What does it mean, Manuel?
It helps us find the hypotenuse. Or not necessarily. It helps us find the missing length.
Helps you find the missing length. And the triangle has to be what kind of triangle for this to work?
Right.
Has to be a right angle triangle, means you've got a 90-degree angle right there. Which sides are which?
The A and B are the shorter sides and C is the hypotenuse.
Okay, so A and B are the shorter sides. It doesn't matter which one is A and which one's B as long as they're one of the 2 shorter ones. So then that's got to be C there. You've probably been using it since grade 8, so I'm going to assume that we're good-ish here. This is a specialized form of what larger equation? Well, 2/3 of you had your hands up before I said you knew it.
What?
This is cosine law. This Pythagoras is just a specialization of cosine law. So I'll give you cosine law. Cos law says that c squared is equal to a squared plus b squared, which is exactly what we have before, except what gets added here or subtracted? Minus, just bringing any memories back to AB, cos of what are, yeah, and we label it, we give it the same letter as the side that it's across from. So in this case, that's side C, that's angle big C, and these would be across from each other. So if we need cosine law, here it is. So this guy would be angle C because that's side C, which means this would be angle A across from side A, and this would be angle big B across from little b here. These are related to each other because in this case, with a right angle triangle, that's 90. Angle C here is 90 degrees. What's the cosine of 90? Does anyone ever put that in your? Did you do that when you did trig last year, grade 10? Have you ever done that before? Grab your calculators if you got one. What's cos of 90? It's 0. So when you've got a 90-degree triangle, we've got cos of 90 is 0, which means 2 times a times b times 0 is 0. So that's where we get cosine law from. So if you've seen it before, there it is again. If this is brand new to you, don't worry about it. There's all sorts of ways around it. But you said you saw it, so we'll bring it back. Okay, so we've got Pythagoras there. And the other trig relationships, there are 3 of them. We've got sine, cos, and tan. Sine theta, cos theta, and tan theta. What are the expressions for these guys? Yeah. That's when we're dealing with when we're in polar coordinates or on a, yeah, we don't want that. Yeah, I want the easy one. O stands for the opposite side. Okay, cool. A stand adjacent, so I'll abbreviate that as ADJ over the hypotenuse. Cool. Tangent is the opposite over the adjacent side. And adjacent means what? For those of us who may not remember. What's the meaning of that word? Next to. And it's the side that is next to the angle that isn't what side? No. That is not the hypotenuse. This side here is always the hypotenuse. So if this is my angle right here, the opposite, sorry, what were you saying, Connor? Say that again?
I'm pretty sure opposite on the bottom is like the adjacent of each other, right?
If this is the angle I'm using right here? If this was the angle we were using, then this would be opposite and this would be adjacent. I labeled this one here before you started talking. Or sorry, after you started talking. So if that's the angle I'm labeling, this side here is opposite, and this side here is adjacent. If this were the angle I was using, that guy there on the top right, I'll zoom this in so maybe it's a little easier to see. Then this side here would be opposite, and this side here would be adjacent. When I teach it to my 9s, sometimes it's hard for them to wrap around their heads that opposite and adjacent can change. They're not dependent on, they're dependent on which angle you're looking at. They're not a standard, like, locked-in label that we give to these sides. So that's trig. You should have, I feel like grade 9, you should have seen that the first time. So just as a general example here, we're going to solve the following triangle. And to solve a triangle means to do what to it? Sorry? Yeah, find all of the missing sides and angles. Find all sides and angles. Okay, cool. So we're going to use a combination of what we looked at before to figure out everything we're missing on this guy here. Oh, yeah. Okay, is that enough? Or I just slide it over there. Okay, so let's solve it. I don't particularly care what order we do this in. We're good now? Okay. Well, actually, I don't actually need to move it over, so we're still good. Manuel, you have a thought?
Yeah, the missing angle would be 60.
The missing angle is 60. Why is the missing angle 60? Ooh, so let's put that other piece of information somewhere. Let's put it down here. Also, as a fun fact, angles in triangles add to 180 degrees. That's cool. We like that. So that one's, so we start with the 180, we subtract the 90 that we're given, we subtract the 30 that we're given, so the last angle there is the 60 degrees. Thanks, Manuel. Cool. Now what? We have two missing sides. What do I do? Yeah, Angelina. If I'm using sine, what angle are you using? Okay, so you're finding this side here. So we want sine of 30 equals opposite, which is x over 12. Cool. So to solve that, what do I do? Kind of, yeah. Yeah, multiply 12 on both sides, so I'm going to get x equals 12 sine 30, which is what? Fantastic. If I didn't want to use sine for this guy, what could I have done instead? And if I'm using cosine, I'm using which angle? Yeah, I could have done the cos of 60. Yeah. So then my last one I've got options for. Let's call this guy down here. I haven't left a lot of space for it, but let's call this side y. So there's three different ways we could find y. What are they? Sorry? I could use Pythagoras to find y. Let's do it. So I've got a squared plus b squared equals c squared. So Manuel, which is which? Or what's what here? Okay, so that's going to equal 12 squared. So I've got 6 squared plus b squared equals 12 squared. Okay, how do I solve that?
I would go just rewrite as 36 plus b squared equals 144.
Okay, so I'm actually doing the, I'm exponentiating. So 36 plus b squared equals 144.
Yes, and then take the 36 over to get b squared equals 108.
B squared equals 108.
And then square root 108.
Square root both sides. So that's going to leave me with b equals what?
About 10.392.
10.392. So in this case, b is y. Yeah? Side that I labeled y. Cool. Is there any other way we could have solved it? It's one way. Give me another one. Someone who's not Manuel or Angelina. Yes, sir. Sorry?
You could, I don't know.
You're withdrawing your hand? Okay. How else could we have solved for y? Manuel.
You use the cosine law.
I could have used, whoa, cosine law. Well, cosine law is just I mean, I suppose there's easier ways to do it though. Don't go that way.
Okay. Then you just use one of the simple trig ratios.
Yeah, I could have used any one of these trig ratios. If I'm looking for this side, and I want to use sine, what angle would I have? What angle would I have to use?
60.
Yeah, the 60. Okay. If I wanted to find this side using cosine, what angle would I use? I heard it, the 30. Cool. And if I wanted to solve for this guy using tangent, you never actually use the 90. You could use either one, right? Because if I use 30, then the y becomes adjacent. If I use the 60, then the y is opposite. Doesn't ultimately matter which one you do. So let's just do one of them just to make sure that Manuel is actually right the first time. Manuel, which one would you like to do to check your first answer?
I would like to use cos.
We like to use cosine. Okay, cool. So if we're using cosine, we already established that we need the 30-degree angle there. So cos 30 equals adjacent over hypotenuse, so that's going to give me y over 12. So y equals 12 cos 30. Let's check your work from the first one. 10.392. We like that. So the more you solve, the more obviously space you have to, it's not space, but more you have to work with, more options you have to work with to solve subsequent pieces of information. Hands up if you're in a math class right now. Which one?
Pre-calc 11. Pre-calc 11.
Is anyone not in pre-calc 11? Which one? Foundation 11. Okay. 11. Back there, yeah. Sorry? Foundations 11. Okay, but so you're all in 11. None of you are in math 12? Okay, cool. Then, sorry, who's in math 12? James. Okay, James, this is for you. At some point in the semester, you're going to start learning about something called radians. When you come back to this class, make sure your calculator is not in radians and is instead in degrees. Because if you leave it in radians when you get to that point in pre-calc 12, everything you do in my class will be wrong. Only because your calculator is computing it differently. So be aware of that. Cool? Okay, so hands up if you're like, yeah, I remember this trig stuff. You're feeling comfortable with trig. Okay, some of those hands went up really slowly. Let's get you practicing some trig. Flip the page. These are the questions I want you to do. I didn't leave you a lot of space to work with. If you feel like you can cram it in there, by all means. But better would be for you to grab your COIL book, your line paper, and to do these questions in there. If you've got comments, questions, concerns about any of these things, let me know. If you remember what angle of elevation is and angle of depression is, sweet. If you don't, let's review that. Let me know. Yes, you can listen to music while you're working on this, Manuel. Give this a shot. I'll come around and let's see how we're doing. Yeah. Take the ruler.